In this video, we'll talk about coin change problem. Let's say we are given a set of coins with values 1, 3 and 4 and we are given a sum of money 10. Our task is to form sum 10 using as few coins as possible. So let's see how it works. Now I can make the sum of money 10 by taking, let's say, 1 twice, so 1 plus 1, and 4 twice, so 4 plus 4 equals 10. Or I can also do it in this way. Let's say I can take 3 twice, so 3 plus 3, and let's say 4 once equals 10. Now both of this approach leads me to the sum 10, but this approach takes 1, 2, 3, 4 coins in total. So I've got 4 coins in this approach, and this approach takes 1, 2, 3, so it takes 3 coins, and therefore I'm going to take the second approach because it takes me fewer number of coins. So that's our goal. Our goal is to use as few coins as possible to make this sum of money. Now for that purpose we are going to use dynamic programming in this case, and let's say we define a function solve x. Now this solve x function returns me the minimum number of coins required to form sum x. Let's say in this case, if I say, let's say I say sum of 10, solve of 10, so it's going to return me 3 in this case because I need 3 coins. I need at least 3 coins to make this sum. Now these are a few values of solve of x. Let's talk about this approach. Okay, solve of 4. Now if I take the sum as 4, I need, how many coins do I need? I can just take this coin alone and it's going to make the sum 4 itself. So solve of x is going to return 1 because I require only 1 coin to make the sum 4. And then let's talk about solve of 0. Now how many coins do I need to make the sum 0? Obviously 0 coins because the sum is 0. So I do not need to take any coin at all to make any sum. So it's going to return me 0. It's actually our base case. We're going to use this condition as our base case in the program. Now let's talk about another condition. Let's say solve of x, let's say minus 10. Now is it really possible? Is there any solution when the sum becomes negative? No, there are no solution when the sum becomes negative, and therefore when the sum becomes negative we're going to return infinity. Now infinity refers to the fact that there are no solutions. Now if we try to define solve of 10, now it can be defined like this. I can say solve of 10 equals minimum of solve of 10 minus the first coin, which is 1, plus 1, solve of 10 minus the second coin, which is 3, plus 1, or solve of 10 minus the last coin, which is 4, plus 1. Now 10 minus 1 equals 9, 10 minus 3 is 7, and 10 minus 4 equals 6. Now solve of 9, solve of 6, and solve of 7. So what does it really mean? All it means is if I take the first coin, so if I take the first coin, let's say if I take 1, then I need only 9 to make the sum 10. This line means if I take the second coin, then I only need 7 to make 10, and the last one means if I take the last coin 4, then I only need 6 to make the sum 10. So solution of 10 is going to be the minimum of all these 3 cases. So the first case is if I take the first coin, then I just need to find out how many ways how many coins do I need to make the sum 9 plus 1. Now why do I have plus 1 in all these cases? Now plus 1 represents that I've taken this coin. For example, solve 7 plus 1. Solve 7 means the minimum number of coins needed to make the sum 7, and plus 1 means I have already taken coin 3, and as I've taken the coin 3, the total number of coin in my hand at the moment is already 1, and plus the solve of 7. Now solve of 7 will return me the minimum number of coins required to get the sum 7. Now solve 7 is going to return me 2, So in this case sol 7 is going to return me 2. So 1 plus it will be 1 plus 2 equals 3. So this whole thing I can just replace it with 3, and let's try to do the same thing with sol of 9. So sol of 9 will return me 3. So it's just 3 plus 1 equals, it's going to be 4. And sol of 6 will return me 2. So the whole thing will return me 2. So 2 plus 1 equals 3. Okay, so if I take the minimum out of these 3 elements, I'll get 3 as the minimum value. And as you can see, sol of 10 is returning me 3, and it means that we need minimum 3 coins to make the sum 10. And as we have seen earlier, we can use 3 twice and 4 once to make the sum 10. Now the question is, how are we going to get the other things, like the other functions, sol 9 or sol 6? Now we're going to use dynamic programming to actually calculate those values, and whenever we'll find out those values, we'll store those in an array. So that we will be using memoization, and it will help us to overcome the overlapping solve problems. Well, now let's jump straight into the code. So first of all, what do I need? I will first declare a variable const int num coins equals 3. It's going to hold the total number of coins that I'm given. Then I'll take another const integer infinity equals 1, just a large value. Then I'll take another const integer sum equals 10. So that's the sum that I'll have to make out of those coins. Then I'll make an array int coins, which will num coins. So it's going to hold all the coins, all the values of the coins that I'm given. Now let me define the function sol. So int sol, it's going to take a sum as parameter. So x is the sum in this case. Let me just write sum instead of x, so it won't make any confusion. Now if sum is less than 0, then we'll return infinity. We have seen why we would return infinity. If infinity just represents that there are no solution for once the sum becomes negative. And if sum equals 0, then we'll return 0. So because when the sum becomes 0, then we do not need to really take any coin, and therefore we are going to return 0. Now I'll define an integer base and assign infinity to it. Now I'll have to use a loop to make this comparison. Now in this comparison, 10 is basically the sum that we are passing to the function, so it's the sum, and 1 is basically the value of the coin, so it's basically coin of 0. And the same way, this one is coin of 1 and this one is coin of 3. And therefore, to make this comparison, we'll have to use a for loop. The for loop will iterate for 3 times, as we have got 3 coins. So I'll take a for loop and I equals 0, I is less than num coins plus I. So the loop will run for num coins time. Now this line can easily be broken down in 3 lines. So let's say sol 10, I'll store it inside the variable best. So b represents the variable best, and I will break down this one statement into 3 lines. So first I can write b equals minimum of b and this one. So this one I can write as sol of sum minus coin of 0. Then I'll just repeat this same line once again, and this time I'll just say coin of 1 instead. So it's going to be coin of 1, and let's repeat this line once again, and in this case it will be coin of 2. Now initially b was instantiated with infinity. Okay, infinity was assigned to the variable best, and therefore we can say after execution of these 3 lines, the minimum of these 3 variables will be stored inside b. So in this case we are using a for loop. And we'll use I as the index of these coin variables. So we can just write base equals minimum of best and sol of sum minus coins of I plus 1. Now all that's left to do after that is just return the variable best. Now this function is going to work if I say cout sol then sum, and remember this sum is defined earlier as 10. Now if I run this program, it's going to output 3. As you can see, we are getting the right answer, but there is a problem. If we simulate this, we'll be able to find out what the problem is. The problem is that we haven't used memoization, and therefore we have got overlapping subproblems. Well, let me try to simulate this and find out what the problem is. So I'm going to find out sol of 10, and this will call 3 functions, or this will call 3 functions recursively. Now for sol 10, how many times is this for loop going to iterate? The for loop is going to iterate for numcoins time, or the for loop will iterate 3 times. Therefore this line of code will execute for 3 times. I'll just copy this line of code and just paste it here 3 times. Now for the first case, best equals this code of line. So what's the value of best? The value of best is in this case infinity, because we have initialized best with infinity. Then sol of sum, in this case sum is 10 in this function, minus coin of I. So for the first time, when the loop will run for the first time, the value of I will be 0. So in this case it will be coin of 0. Now coin of 0, the coin of 0 is actually 1. This was our coin values 1, 3 and 4. So coin of 0 will give me 1 actually. So sol of 10 minus 1, or we can just write sol of 9 here instead, plus 1. Okay, and similarly here the value of best is infinity, and here I'll write sol of sum is 10. So 10 minus coins of I. So in this case the loop is going to run for the second time, and the value of I is going to be 1 in this case. So coins of 1 and coins of 1 will return me the value 3. So 10 minus 3 will return me the value 7 plus this 1. And the same way here the value of best is infinity, and here we'll just calculate sol 10 minus 4, 6 plus 1. Now that's how it's going to work for rest of the simulation. Okay, now sol 9, it will also call itself 3 times. So infinity, then sol of, in this case the sum I'm passing is 9, so it's going to be 9 minus, if I take the first coin, it's going to be 9 minus 1, or 8 plus 1. Then infinity, sol of 9 minus 3 is going to give me 6 plus 1, and then infinity, sol of 9 minus 4, it's going to give me 5 plus 1. Now that's how it's going to branch out again and again, and it's going to call itself again and again until it goes and hits the base case. At some point it's going to find the minimum of say infinity, then sol of 0 plus 1. Now sol of 0, it will return value 0. Now the minimum of infinity and 0 will return the value 1. Now sol of 6, now 1 will be assigned to sol of 6. I can write 1 here instead. So 1 plus 1 will return me 2. So the minimum of infinity and 2 will return 2 in this case. Now the same way these terms will also be evaluated to some values, and they might return you some random values, let's say 4 and 3. Now 4, 2 and 3. So 2 is minimum, so 2 will be returned, and then infinity and 2 plus 1. So the minimum of infinity and 2 plus 1 will return 3. Maybe this solution is going to return you 4, or this solution is also going to return you 3, or something like that. So the minimum of these 3 values will be assigned to the value sol of 10, and thus 3 will be assigned to solution of n. So that's how it's going to work. But there is one problem, that is overlapping subproblem. Have a look at the diagram. Here we are calculating for the value of solve 6, and here as well we are also calculating the value of solve 6. So we are calculating the same value twice. As you can see, we are calculating the same value twice. We actually do not need to come here and calculate it like this. All we can do is, when we calculate a value, let's say I've got value 2 for solve of 6, we can store it inside our memory, and whenever we'll find the same problem, we'll just use the previously calculated value. So inside our code, we'll have to just fix a few lines. We'll just add a few lines of code. We will add an array to store the value. The size of the values array is going to be sum plus 1. So all the values are going to be stored inside this value array, and at the same time I also need another array. Let's name this array as ready sum plus 1. So how it works is, it's a global array. As it's a global array, initially all the values of this ready array is going to be initialized to 0 automatically. Now whenever I find a solution, let's say I find the solution for 10, then what I'll do is I'll just go to the ready array and assign the ready of 10 equals to 1. So ready of 10 equals 1, it means that the solution for sum of 10 is already calculated, and if the value of ready of 10 is 0, it means that the sum for 10 is not calculated. Now if I find that ready of 10 is 1, it means that the calculation for sum of 10 has been done and it has been stored inside the value array. And therefore to find the previously calculated sum, I'll just use the values array, and I'll just use the value 10 to find out the previously calculated sum. So inside our code, we'll have to make a few minor changes. We'll say if ready of sum, if it has already been calculated, then no need to do all these steps once again. We'll just return the value of sum from here. Now if the value has not already been calculated, then this if statement will not work. This line of code will execute. Let me just remove the last line. So this block of code will execute. So the calculation for that particular sum will be calculated in these lines. After the execution of this line, or after the calculation, solution for that particular sum will be saved inside the variable base, and as we have all calculated the sum, we will just set ready for that particular sum equals to 1. It means that we have successfully calculated the result for that particular sum, and we'll have to store the value of that calculation in the value array. So we'll say value of sum equals best, because remember the result is saved inside the value base, and afterwards we'll just return the value of sum. So that's it, and sorry for taking so long to explain this problem, and thanks for watching this video.